plus 3 is greater than 2/3. And that was page 62, number 9. Okay. I need fractions to add fractions, right? So I'm going to take this 3 and I'm going to turn it into something thirds. I want it to be a fraction, right? To take any whole number and turn it into a fraction, you're going to take your denominator that you want, which in this case is 3, and I'm going to multiply 3 times 3 to get 9. Okay, if I had, let's say 3 and I wanted to make it something fifths, I would do 3 times 5 and I would get 15. So 3 is the same thing as 9/3 or 15 fifths, 6 halves, 21 sevenths. That's how you turn a whole number into a fraction.
I thought you just put a 1 on the bottom.
That's also a fraction, but 2/3 plus 3 over 1. I have to have common denominator.
Okay. Is that in any algebra?
Mm-hmm. Yeah. So we have to have a common denominator. So if it's less steps to take and just multiply by the denominator you want than to turn it into 3 over 1 and then find the common denominator and then multiply it out. But we can do that. If I want 3 over 1 and I need to make it into thirds, I multiply this by 3, I multiply this by 3. See how it's kind of the same thing? Okay. So I'm going to take that z plus 3, and it's going to be z plus 9/3. So same, 9/3 and 3 are the same. I'm going to subtract 9/3 from both sides. And I'm going to get z is greater than -7/3, because 2 minus 9 is -7. All right, so we have two fractions, right? These are fourths and these are halves. So I want to find the common denominator. 4. So I'm going to turn this into fourths by multiplying by 2 and 2. So I'll have 2/4 is less than or equal to c minus 3/4. And then I'm going to add 3/4 to both sides. And I'll get 2 plus 3 is 5, so I'll have 5/4 is less than or equal to c. And that's perfectly acceptable. You can leave it improper. Now, if you had done it with decimals, it would have turned into that. And these are okay because these are perfect decimals. They end, right? So it would be the same thing. I would just add 0.75 to both sides. 0.75, not 75. And I get 1.25 is less than or equal to c. This on that are the same. Okay? Compound inequality. Okay, you remember what compound sentence is? Is when you take two sentences and you put them together? That's what a compound inequality is. As I take two inequalities and I put them together. And with and or, just like a sentence. Okay, we put them together and we make a compound inequality. So, hold on one, just checking. Okay, the and inequalities are called intersections. Okay, if you're thinking about and, that's where the two things combine. And combines two things, so they overlap, right? I only like polka dots and stripes. So if I was going to go shopping, I wouldn't buy anything with polka dots only, and I wouldn't buy anything with stripes only. I only like polka dots and stripes, so I would buy polka dots and stripes together, the overlap. Okay, so intersections, and it's the same thing on a road. Intersections happen where two roads overlap. The intersection is that overlapping part, right? Think about that. Well, it has, one solution, but it's a compound solution. It's an overlap. Okay, it's only true for both things. Okay, so here's what'll work. If I have x is greater than 6, okay, so here's 0, 1, 2, 3, 4, 5. No, make that negative 6. Sorry, negative 6. 1, 2, 3, 4, 5, 6. Negative 6. Okay. X is greater than negative 6. If I graph that, I'm going to have that open circle here. And I'm going to come along and I'm going to graph all of this. Okay. Good? So far? Well, then I have x is less than 2. We'll do less than or equal to 2. So here's 0. Here's negative 6. Here's 2. It's less than or equal to, so I'm going to color that circle in. And I'm going to shade all of this. With me so far? Now, our compound inequality, our intersection, has the word and in it. X is greater than negative 6 and x is less than or equal to negative 2. So it's only the parts that overlap. Here's negative 6. Here's 2. Everything over here is going to go away. And everything over here is going to go away. Because we only want the part that's and. So the part where the two graphs would overlap. So what will happen is I'll have an open circle on, oops, wrong pen. I'll have an open circle on negative 6. I'll have a closed up circle on 2. And I'm going to shade that bit in between because this is where the two graphs would overlap. With intersections. Let's make some number lines. Got a number line, I have another number line, I have another number line. Okay, if I have x is greater than 3, so here's 0, I'm just going to say this is 3. That's going to shade over here, right? And then I have x is less than negative 1. So here's negative 1. And that's going to shade over here. And intersections are only overlaps. Does this overlap at all? Right? They don't have anything in common. There's no overlap. So if that occurs, you get no solution because there's nothing overlapping. So there's no number that would make this true, that it's both greater than 3 and less than negative 1. Okay, here in our example where there's an actual overlap, there are lots of numbers in between negative 6 and 2 that are true, that are bigger than negative 6 but less than 2. Right? We've got negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, and it's less than or equal to, so and 2, and then every fraction and decimal in between those. So there's lots of numbers that are in that overlap. So that's what we're talking about. We're talking about every number that's between here. Whereas if we have this one, there are no numbers that are greater than 3 and also less than negative 1, so there's no solution for this. Okay, so for an intersection, there has to be an overlap. Okay. Okay, and these are the word and. Now, sometimes they don't actually use the word and that's when you get in a situation where it's in compound form like this. But I'll show you how to solve these in a second. Okay, we have y minus 3 is greater than or equal to negative 11 and y minus 3 is less than negative 8. Okay, so it's got to be true for both of these statements. So I'm going to solve these individually. So we're going to solve individually. Okay, so I'm going to add 3 to both sides here. And I get y is greater than or equal to negative 8. Okay. Yeah. I'll add 3 here, and I get y is less than or equal to negative 5. And it's still and. So to graph this, I pick a 0. I'm going to pick 0 over here. So I have 1, 2, 3, 4, 5. That's negative 5. 6, 7, 8. That's negative 8. Now to figure out, first of all, it's going to be a closed circle because it's less or greater than or equal to. Well, greater than or equal to would shade that way, correct? And over here I've got less than or equal to, so it's a closed circle, and less than or equal to would shade that way. So do you see how by shading this way and this way, I get that overlap in the middle? Okay. Now if both arrows pointed the same way, I would just shade that way, because it would, from here, because this part would overlap. Does that make sense?
So y has to be between there somewhere.
Yeah, y has to be between here somewhere. It's going to be...
It could be negative 6 or 7.
Or 7, or any of these fractions or decimals in between. Because it has to be both greater than negative 8, or greater than and equal to negative 8, and less than or equal to negative 5.
Is there another way to find out what it is or not?
Not really.
Not possible at all?
No, you just have to solve them. Now, do you necessarily have... Okay, sometimes they're written like this. And what you want to do is, basically this has 3 sides. Right? So it's kind of got 3 sides. It's got the right, the left, and the middle. Right? Left, middle, right? 3 sides. So whatever you do to one, you have to do to all 3. Okay? So I'm looking at this x, and I'm going to add 3 to get rid of it. Well, if I add 3 here, I have to add 3 here and here. Okay? And I'll show you another way to do this as well if this is uncomfortable. So negative 2 plus 3 is 1. It's still less than or equal to. There's an x. It's less than 4. The nice thing about these is see where x is? X is in the middle, so that tells you where to shade. You shade in the middle. So all I have to do is I have to put in my 0, I put in my 1, I put in my 4. This is a closed circle. This is an open circle. And I'm shading in the middle because the x is in the middle. Now, does anybody want to see the other way? The other way to solve that kind. So it was negative 2 is less than or equal to, wrong pen. Negative 2 is less than or equal to x minus 3, which is less than, 4. Oh my gosh, that's not a 4. 4 plus 3 is not 4. 4 plus 3 is 7. Duh. Catch me when I do silly things. Sorry about that. Okay, so 4. That's 4. This was not. All right, if you don't like solving it and doing things to 3 parts, you can split this. This is the same thing as negative 2 is less than or equal to x minus 3, and x minus 3 is less than 4. So you just take that middle part and write it twice with an and in between it. And then you can solve them separately. And I get 1 is less than or equal to x. And then when I solve this one, I'll actually add correctly this time. And I get x is less than 7. So if the putting them together like this is too visually straining, Or if you don't like it, you can split them. Or you can solve it together. It's a matter of preference. Both ways. All right, so we're going to do it together over here and apart over here. So if I split it apart, get that. Okay, which I can solve each individually by subtracting 7 from both sides. And 6 minus 7 is -1 is less than r. And if I subtract 7 over here, I get r is less than -7. Or sorry, why am I writing -7? I can't apparently add and subtract today. If I do it together, I subtract 7 from all 3 sides. And I get -1 less than or equal to r less than 3. In any case, I have to identify a 0, a -1, and a 3. This is going to be a closed circle, open circle, shade in between. We have another and that's separate, and see how these don't match? That's why you can't put them together. So we'll subtract 2 from this one, and I get n is less than -7. I'll subtract 6 from this one, and I get n is greater than or equal to -12. I say this is 0, I get 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, wait, whoops. 8, 9, 10, 11, 12. I have an open circle on my -7, and it's less than shades that way. I have a closed circle on my -12, and greater than shades that way. So I'm shading in between. Let's do a hypothetical. Let's say hypothetically you have x is greater than 3 and x is greater than or equal to 6. That gives me an open circle that shades this way. And I have a closed circle that shades this way. See how they both are going to shade that direction? I'm only doing the overlap. No, it would only be no solution if the arrows pointed in opposite directions. But it's overlapping from here on, right? Because this would shade all the way over here, and this one's going to shade all the way over here, so it's going to overlap just here. Does that make sense?
So you don't shade between?
You can't shade between because it's and. Okay. So the arrows are both going in the same direction, so you shade this way. If it was the other direction, let's say it was less than 3, less than -6, it would shade that way. Does that make sense? Okay, so it's only a no solution if it's an and they face opposite directions. Okay. Then we have what's called a union. And what happens when you have a union? Ooh, wrong pen again. Unions are joining, right? You get married, that's a union. And what happens? You don't only keep the stuff that overlaps, you end up keeping everything. Everything, your whole life gets put together, right? So unions are joining, so it's, whereas an intersection is an overlap, a union is a joining, so it's all of everything. Or all of both. Okay, and they're or. I like stripes or polka dots. That means if it has stripes on it, I'll get it. If it has polka dots on it, I'll get it. I'll get both. If it has both, I'll get that too. Everything with stripes and polka dots. So the way this would work is if I have x is greater than 7, say this is 0, that's 7. So x is greater than 7. When I shade that, I'm shading this way. And if I have x is less than 3, so here's 3. So if I shade that, I'm shading this way. And if I have both, x is greater than 7 or x is less than 3, I'm combining the two to make one. So it's not just the overlap, it's everything from both. So I have all of this one and all of that one. So you put them together to make one. So it seems kind of counterintuitive because you would think an and is put together to make one, but it's an or that you put together to make one. It's an and that's just the parts that overlap. Okay, so combine. Okay. What we do is we solve them separately. Now there's the way the and was where you had them put together into a single inequality. That doesn't happen in a union. It's always going to be two separate ones with the word or in between them. So I have minus 7, minus 7. So negative 2m is less than or equal to 6. Divide by negative 2. And I get m is greater than or equal to negative 3. And I come over here and I have minus 12, minus 12. Huh. I think that was meant to go this way. Oh well, anyway. Doesn't matter. So I get 5m is greater than 25. Divide by 5. And I get m is greater than 5. So here's 0. I have negative 3. I have 5. Greater than or equal to negative 3 gives me a dark circle and I'll shade that way. Greater than 5 gives me an open circle and I'll shade that way. But because I'm combining the graphs, I'm going to shade both of them, the whole thing. Okay. Normally in a union they point opposite directions, but this one just happened to point the same direction, and that does happen, so you just shade everything that it needs to shade. For our next example, subtract 1. I get a is less than 3. Add 1. And I get a is greater than or equal to 4. And just to make it spaced out, I'm going to count these as 2's. So I'll say 1, 2, 3, 4. So it's more spaced out, so it's easier to see. Less than 3 is an open circle, and I'm going to shade that way. Greater than or equal to 4 is a closed circle, and I'm shading that way. But because it's a union, I do both. So basically every single number except what's in between 3 and 4 makes this true. Add 7 to both sides, and I get 4k is less than or equal to 32. Divide by 4, k is less than or equal to 8. Subtract 12. Negative 9k is greater than or equal to 8. Divide by negative 9. And k is going to be less than or equal to 8 ninths, negative 8 ninths, and it doesn't matter. I don't need to know what that number is. I'm just going to, I know it's a little less than 1, so I'm going to call this 0. I'm going to call this negative 8 ninths for the heck of it. I'm going to call this over here 8 because it doesn't really matter. Closed circle that shades this way. Closed circle that shades that way. It's a union, so I shade them both. Okay. If I subtract 2 from both sides here, I get 4x is greater than 8. You're going to divide by 4, and you get x is greater than 2. And when I come over here, I'm going to add 5. Oh, wait, no. I didn't change that properly. Make this positive and make that negative or positive, and then that'll change it correctly. Sorry, I was changing it, but I didn't change it correctly. So we're going to subtract 5 from both sides to get 3x is less than 27. If I divide by 3, I get x is less than 9. Okay. So here's 0, here's 2, here's 9. X is greater than 2 would shade that way. X is less than 9 would shade this way, and it's a union, which means I'm shading them both because it's an OR. So here's what would happen. I'm going to shade this one, and I'm going to shade all the way over here. And then I'm going to take this one, and I'm going to shade all the way over here. If this occurs, it's wrong pen again. It's all real numbers. Because everything greater than 2 and everything less than 9 is, we've got the OR, so it's everything. Every number would make that true. X is greater than 2 or x is less than 9, that's everything. Everything is either greater than 2 or less than 9, right? So when you shade the whole thing, your answer is all solutions. So when you have intersections, wait, where was it? Here, where you have no overlap, you have no solutions when they're facing opposite directions. And then when you have unions, and then they end up facing in opposite directions towards each other, you get everything. Does that sleep? Okay, so the human ear can only detect sounds between the frequencies of 20 hertz and 200,000 hertz. Okay, if I'm between, that means it has to be right between the two. I can't hear anything below 20 hertz, and I can't hear anything above 20,000 hertz. So I'm gonna, that's writing the compound inequality. Does that make sense? Because it's between, x will be between. And then because I'm not going to be able to write this to scale, I'm just going to arbitrarily pick. Just because my number line's not quite big enough to go up to 20,000. So, questions on that at all? Okay. Here we have 8 less than a number is no more than 14 and no less than 5. This is that compound inequality, and here I have OR. So I can either write this as 2 statements or 1. I'm going to write it as 2 because I think it's just going to be easier that way. So if 8 less than a number, that's x minus 8, is no more than. So that means it has to be less than or equal to 14. And, so x minus 8 again, no less than. So it has to be greater than or equal to 5. So I'm going to add 8 to both sides. And I'm going to, x is less than or equal to, what is that, 22? And then I'll add 8 over here. And I get x is greater than or equal to 13. And again, it's still and. And there is a solution because they're going to be shading from below 22 and above 13, and you'll have that overlap in the middle. Does that that make sense? We have the product of -5 and a number. So this is multiplication, right? So it's -5x. Is greater than 35, okay, or less than 10. So I had still the -5x less than 10. And it told us or. So I'll solve these each individually. So I divide by -5. Divided by a negative, so I flip. So x is less than -7, or divide by -5 again. And I'm going to get x is greater than -2. And it's a union, so if you were to graph this, you'd graph both. Okay, so we've got Yuma is selling gift cards to raise money for a class trip, and he wants to earn prizes, and he has 34 cards, and he wants to earn a prize in category 4, so that's this category. So we need 46 to 60. Well, he has 34, so we want to know how many more does he need, and he has to have at least 46, but at most 60. So the x plus 34 is going to go between 46 and 60. Does that make sense? Why it would go there? Okay, so then we subtract 34 from both sides, or all three sides. And I get 12 or 26. So he has to sell between 12 and 26 cards more to get that